Chem Exam Explained, where the aim is chemistry clarity exam mastery. In today's video, we will be looking at CSEC Chemistry, May-June 2012, question number 4. Question 4, Part A. Radioisotopes are very useful in everyday life. For example, uranium-235 is used in energy generation because it produces large amounts of energy when the atoms split. State 2 other uses of radioisotopes and explain the importance of each. 1. Carbon-14 dating. This is used for finding out the age of one's living or archaeological specimens. 2. Tracers. These are substances containing very small quantities of radioisotopes that are used for easy detection and measurements, often used to study chemical changes within living organisms. 3. Radiotherapy. This is used to treat cancer cells because it destroys cancer cells more rapidly than normal cells. And 4. Pacemakers. This is a small device that is placed in the chest or abdomen to control abnormal heart rhythms. They are powered by the energy produced by the radioactivity. So these are 4 uses. You can use any 2. 4b. The properties of elements can be explained based on their electronic configuration and hence their position in the periodic table. The electronic configurations of 4 elements P, Q, R, and S are P27, Q282, R286, S2882. B. Part 1. Outline the criteria for placing elements in the periodic table. Hence, state the appropriate grouping and period for each of the elements P, Q, R, and S. So let's answer the question. Generally, elements are placed in order of increasing atomic number. The number of valence electrons determines the group, and the valence electrons are the ones on the outer shell, and the number of shells determines the period. So element P is in group 7, period 2. Element Q is in group 2, period 3. Element R is in group 6, period 3, and element S is in group 2, period 4. B. Part 2. Elements P and Q react together to form a compound. Deduce whether the compound is ionic or covalent. Use dot cross diagrams to show the bonding in the compound formed and write its formula. Looking at P, we see that the number of electrons on the valence shell is 7. So we have 7 electrons on the valence shell. So this is in group 7. So it is a non-metal. Looking at Q, it has 2 electrons on the valence shell. So Q is a metal. So right away, we know that the bonding between P and Q is ionic. Now, if we are going to be putting P and Q together to bond it ionically, we must first look at how the elements are arranged and what charges they carry. So Q would carry a 2+ charge since it has 2 electrons on its valence shell. So to become stable, when it loses those 2 electrons, it carries a 2+ charge. P would carry a negative charge since it must gain an electron to become stable. Looking at these 2 things, in order to combine them, the compound must be electrically neutral. So what we're familiar with is to cross the 2 over here and the 1 here and to write the formula QP2. Or what I like to do is to make sure it is electrically neutral. So what I say is I have 1 Q that carries a 2+ charge, 1 P that carries a negative charge. In order for this to be electrically neutral, I need another P. So now I have 1 Q with 2 P's. And that's the formula I'm going to be using to draw my diagram. So I need to have 1 Q that carries 2 electrons on the inner shell, 8 in the middle shell, and the outer shell carries 2. And then I have 2 P's, each carrying 7 electrons on the valence shell. And so the metal must lose one electron to each of the P's. So one electron will be lost from the Q to the first P, and the second electron will be lost from the Q to the second P. This gives me an ionic compound. And this is the diagram that shows you how we bond one Q with two P's, metal and non-metals, to form our ionic compound. Now you could do separate P's but have only one charge here. So notice I have two P's with a single charge because they are separate. Or instead of putting a 2 here, I could draw them separately and put the square bracket with a negative charge for each of them because they are now stable. B, part 3. Compare the reactivity of each of the elements Q and S with dilute hydrochloric acid. Write a balanced equation for either of these reactions with dilute hydrochloric acid. So again, let's look at Q. We see that Q is a metal with 2 electrons on the valence shell, and S is also a metal with 2 on the valence shell. But you'll notice that the valence electrons in S is further from the nucleus than in Q, which would make S more reactive. Hence, even though both would have the same type of reaction, the reactivity would be more vigorous in S than in Q. So to answer the question, Q and S are in the same group of the periodic table. Element S is lower down in the group than Q, therefore S is more reactive than Q. Hence, element S would react more vigorously with dilute hydrochloric acid. Now remember, we can do either of the equation because they react the same way. So you could say S, solid, because it's a metal, plus hydrochloric acid, aqueous, produces S chloride plus hydrogen gas. Same thing with Q. Same Q, solid, reacting with hydrochloric acid to form Q chloride plus hydrogen gas. So the reactions are the same. The only difference is the vigorousness of the reaction would be greater in S than in Q, since S is more reactive. Notice you must put in your state symbols and the equation must be balanced. Let me note one thing here. It is very important that you write the correct formula for the salt. So since we know that S has 2 electrons on its valence shell, it will carry a 2+ charge. And S will displace the H from the HCl. So I'm combining S with Cl. Now I have S with a 2+ and Cl with a minus. So I need another Cl for it to be electrically neutral. And so the formula would be 1S with 2Cl. And that's your salt. This is the end of CSEC Chemistry, May-June 2012, question number 4. Please remember to like, subscribe, and click the notification bell so that when new videos are uploaded, you will be notified. Thank you.